A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheel. The mass of the cart is 3 kg. Suppose if we take the diagram, so the diagram is already given it here. So a girl, her mass equal to 40 kg. 40 kg is her mass, and she is jumping with a horizontal velocity. So this is the velocity of the girl, and she is jumping on a stationary cart. So this cart is stationary, means the cart is at rest, but the mass of the cart is given that 3 kg. After jumping the girl on the cart, what happens? So they both will move together, the cart and the mass. So that is also shown in the figure. So the girl and the cart, so they both move together. After jumping. Now here we need to calculate what is her velocity as the cart starts moving. When she is running and jumping on a stationary cart, so after that the cart along with the girl, they both move together. They are moving with a velocity v. So we need to calculate what is the velocity of her. And here they give certain assumptions. That assumptions that there is no external unbalanced force working on the horizontal direction. It means there is no another external force. Forget about all this wind and any kind of the external forces are there. So let me take this is as a two-step problem. So I can take that before. So this situation we can consider that before jumping, and this situation after jumping. So we can apply the same law of conservation of momentum formula. So to apply that, first we need to calculate the total momentum. So let me write that first. Let mass of girl m1 equal to 40 kg and mass of cart, the stationary cart, mass of cart m2 equal to 3 kg. So velocity of the girl, velocity of the girl, let me take this as initial velocity u1 equal to 5 meter per second, and initial velocity, let me take this as initial, or initial velocity of the cart, that equal to u2. The cart is at rest, that equal to 0 because it is at rest. Now we need to calculate that momentum of the girl. Momentum of the girl, so that I can write that m1 u1 which equal to 40 times 5 which equal to 200 kg meter per second, m1 u1. Now momentum of the cart, so that equal to m2 u2. The cart mass 3 kg, but velocity equal to 0, so its value goes to 0. So these two values I will use it. So one is m1 u1, the momentum of the girl, 200 kg meter per second, and m2 u2 that equal to 0. Now total momentum before jumping. Total momentum before jumping. So what we shall do, we need to add these two, that equal to m1 u1 plus m2 u2. So I can get that 200 kg meter per second plus 0. So you can get that total momentum before jumping m2 u2 is equal to 200 kg meter per second. So this is total momentum of girl along with cart before jumping. What is the total momentum in this case? So in this case total momentum I got that 200 kg meter per second. Now we need to get after jumping. So now to find the after jumping, now after jumping, if you can notice the diagram, the girl and the cart, they both are moving to the same velocity. Since the girl is on the cart, so velocity of the cart and velocity of the girl, they both are the same. So here that velocity is mentioned as v. So we can take that after jumping, mass of girl remains same and velocity of the girl, if I can take that v1 is equal to v, and similarly velocity of the cart and v2 is also equal to v, and mass m1, the girl mass is 40 kg, that is do not change, and the mass m2, mass of the cart, that equal to 3 kg, so this is also do not change. Now let's write that momentum of the girl after jumping. Momentum of the girl is equal to 40 times v, and momentum of the cart is also equal to 3 times v. Now total momentum after jumping, I can write that we can add these two momentums, which equal to m1 v1 plus m2 v2. Sum of this 40 times v plus 3 times v is equal to 43 times v. That is the total momentum after jumping. Now here we can apply law of conservation of momentum. In this situation, total momentum before jumping equal to total momentum before jumping, which equal to total momentum after jumping. Total momentum after jumping. Now we have the two values. So here the total momentum before jumping, so we got that as 200 kg meter per second. So this is the total momentum before jumping, and total momentum after jumping, so here we got that as 43. So let me take as 2 this equation, and this is a 1 this equation. So equating 1 and 2, therefore 200 kg meter per second is equal to 43 times V. So let me take out the units so that's things easy for us. So it is 200. Now if you can calculate that for V, so velocity V equal to 200 upon 43. So if you divide this 200 upon 43, 4.651. So this is the velocity of the girl along with cart. So V equal to 4.651 meter per second. It means the girl is the girl along with the cart. So if I can take this figure, if I can write this as the girl in the cart, the girl and the cart moving with velocity of 4.651 meter per second. So this problem we solved by using law of conservation of momentum.